Hello and welcome to Radicals 3.2 Part 1. Okay, so today's lesson I'm going to split the lesson in two pieces because this is a kind of big lesson. I think there's in total 21 problems for both lessons, so I didn't want to do all 21 in one shot, so therefore I'm splitting it into two parts. Okay, and your homework is also going to be split into two parts as well, so we made each assignment a little bit smarter than usual. So hopefully that helps out as far as getting everything done, and yeah, let's go for it. Okay, so this lesson, typically I'm just going to warn you right now, is one of the harder lessons of the year. And a lot of students get really confused because there's so many different problems that you guys have to learn in one lesson that it gets confusing and the rules get all mixed up. So use this video, try to watch this as many times as you need, and yeah, good luck. Good luck, people. Okay, so this first one, our job is to rewrite this problem in what is called radical form. Okay, so currently it's in what is called exponent form. Okay, and you can tell that it's an exponent form because if you look at the power, yeah, it says 5/6. It's a fraction. Okay, so therefore it's in exponential form. All right, and when we write it in radical form, we're gonna take away the fraction, and that fraction is gonna form a certain type of radical. Okay, so let's write this problem out first. Actually, that's a good idea. So this problem is going to be written as x to the 5/6 power. And whenever you write fractional exponents, you want to write them up and down. Yeah, you don't want to. I mean, you can write it side by side like it is in the handout, but when you guys actually start to manipulate these things, you wanna write it vertically. It's a little bit easier. That's just my preference, but yeah, I found that it's easier if you write it vertically. But you can develop your own, I guess, feeling for what you wanna or how you wanna write it rather. Okay. So basically what this is it's an exponent, it's a fraction, and each part of the fraction tells you information about what's going to happen to the x. Okay, so the top of the fraction tells you something, and the bottom of the fraction tells you something. Okay, so the job of the top of the fraction tells you how many x's you have. So since there's a 5 on the top of the fraction, that means you have 5 x's. So let's write 5 x's, or x to the fifth rather. Okay, the number on the bottom of the fraction tells you what kind of radical it is. Okay, so basically I like to just call it a sixth root radical. So I write the radical symbol, and then I put a 6 in that little crack part. Yeah, and that tells me it's a sixth root radical. Okay, and basically if I want to do anything to simplify this problem, I need to find 6 things that match, and if I find 6 things that match, I can circle it, and I can bring it outside. But unfortunately, I only have 5 x's. I don't have 6, so therefore nothing's going to get circled. So this is actually another problem. Okay? And this is what you call radical form. So we turned it from exponential form, where your exponent is showing, into radical form, where you take apart the exponent. Top of the fraction tells you how many x's we have. Bottom of the fraction tells you what kind of radical it is. And we turn it into radical form as a result. Okay? All right, letter B. This one is y to the negative 7/9 power. Okay, so the top of the fraction, same thing. We still got 7 y's, so I'm going to write 7 y's. The bottom of the fraction still tells me what kind of radical it is. It's a 9th root radical. So make a big square root symbol and put a 9 in that little spot. And that 9 tells me, like I said earlier in the previous problem, it tells me how many things need to match if I'm going to circle it. So if I see 9 y's inside that radical symbol, then I can circle all 9 y's and they can come outside. But unfortunately, there's only 7, so therefore I'm not going to circle it. Okay, and now comes the negative part. So the negative also has a very different role, yeah, from the numbers, the top of the fraction and the bottom of the fraction. So the negative says you're going to put the entire radical, yeah, the 9th root radical of y to the 7th power, you're going to put that on the bottom of a fraction, and you're going to put a 1 up top. Okay, so there's your final answer. Yeah, so that negative just says to put that radical, or to put the letter y on the bottom of the fraction. Okay, or in the opposite location if you want to think of it that way also, because the y is currently on the top, right, and the negative says put him on the bottom. So it gives you a sense of where he's going to be headed. Okay, And I'm sure we're going to get more negative exponents in the future. So if you didn't catch on the first time, then you'll see more examples very soon. Okay, going on to letters C and D. So now we have multiple letters in the problem, and each letter has its own fractional exponent. So let's start writing everything out. So we got x to the 4/3 power, and we got y to the 2/3 power. Okay, so what kind of information do we have? Well, we realize that both x and y are going to be put in the exact same radical. They're both going to be put into a cube root or a third root radical, whatever you want to call it. So that's why I just make one ginormous third root radical, because that's where they're both going. They're both going inside there. Okay, and inside that third root radical, or cube root if you want to call it that, there's going to be 4 x's and 2 y's. Okay, and this time I think I'm going to be able to circle things and have them match and bring them outside, because I have a feeling I have enough x's so that I can circle stuff. So I'm going to write out 4 x's. Oops, how come it's not writing? 1, 2, 3, 4. And I got 2 y's. Okay, so if I wanna bring anything outside, I have to circle at least 3 things that match. So let's see, do I have 3 x's that match? Yes, I do. Do I have 3 y's that match? Unfortunately, I don't. I only have 2, so I'm not going to circle that, but at least I did circle the x. So then I'm going to bring that x on the outside. It's still a cube root radical, or third root radical, whatever you want to call it. There's still an x that got left behind. There's 2 y's that got left behind. So put everybody back together again, and this is my final answer. Okay, and just keep in mind you wanna write it in radical form. Okay. All right. So let's look at letter D. So letter D. Okay. So let's see what this guy says. So it says x to the 13 over 5 power, and it says y to the negative 5/8 power. Okay. So that negative is going to tell me to do something right off the bat. Okay. Let me actually make that negative a little bit more obvious, because I put the fraction line and the negative sign too close to each other, so it looks like it's one big line. So make it separate. Okay, so that negative that is with the negative 5/8 power, he's going to tell me to put the y underneath the x. That's what the negative does. The negative says to grab the entire thing and put it in a different location. Okay, so in this case, the negative is going to either tell the y to go up top, or it's going to tell you to go on the bottom. But since the y is kind of considered on the top, right, because there's nothing underneath it, right? So that's why you know it's going to be going on the bottom. Yeah. Then when I rewrite this problem, it's going to look like this. Okay, so just imagine that negative symbol, yeah, that negative sign is telling you where to put the entire y to the 5/8 power, and he's going to be put underneath the x, and the x just stays where he is because he has a positive power. Okay. So the only one that had to move was the y, because he had a negative power. Okay, so what do we have next? So it says we have 13 x's. Okay, so let me just write this horizontally. So we have 13 x's, and all of those 13 x's are going to go into a 5th root radical. So let me make my radical symbol a little bit on the bigger side, because I got to write 13 x's inside there. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, so there's my 13 x's. And on the bottom, I have a different radical. I have an 8th root radical, and inside him, I got 5 y's. So let's make a big radical symbol on the bottom, put a little 8 in that little space because it's an 8th root radical, and put 5 y's inside there. 1, 2, 3, 4, 5. Okay, so there's my 5 y's. All right, so I'm going to get my red pen out, and I'm going to circle things that match. So on the top, I got to find 5 things that match. So let's see, do I have 5 things that match? I think I do. So there's 5 x's. I'm going to circle that. And on the bottom of that, I also have 5 more x's. So I'll circle that. Okay. So up top, 2 x's are going to jump outside, and 3 x's are being left inside, because I didn't have 5. I only had 3 left, so I can't circle them. On the bottom, do I have 8 y's? No, I only have 5 y's. So therefore, I'm not going to circle anything on the bottom. And I'm just going to put everything back together again. So let's see what I got. So x is on the outside, so x squared on the outside. Then it's a 5th root radical. Okay, so make sure when you do this now, you see how I write my radical symbol? I make the radical symbol, I put that little tail part really high so that you don't think it's a 25. You see that there's separation between 2 and 5. Because I have a lot of students that when they write it, they get messy. and they write the 2 and the 5 too close to each other, so it looks like it's a 25 instead. Or it looks like it's x to the 25th power. Okay, so you want to make that line a little bit higher so that you can tell that the 2 and the 5 are supposed to be separate. Because if not, I'm going to mark you wrong. Okay, so be careful with that. Then it's x to the 3rd on the inside. And on the bottom of that, we have 8th root radical of y to the 5th. And put all those 5 y's together and put y to the 5th. Okay, and there's your answer. All right, so moving on. Number 2. Okay, so now we're going to go the opposite direction. So in the first 4 problems that I just did, we went from exponent form to radical form. In problem 2, we're going to go the opposite direction. We're going to go from radical form into exponent form. Okay, so we're just going to have to take apart what we did the previous problems. All right, so in this problem, let's write it out. Okay, let's start dissecting what it says. So it's a 4th root radical, and I have 3 x's inside of it. Okay, so let's write this out. So I'm going to keep the fraction 1 on the top, and I know I have 3 x's, so I put the 3 on the top of the fraction. And it's in a 4th root radical, so therefore I put the 4 on the bottom, right? Because the top of the fraction tells you how many x's I have, and I have 3 x's. The bottom of the fraction tells you what kind of radical you put those 3 x's inside of. And in this particular case, it was a 4th root radical. And there you go. And just keep in mind, yeah, when I do some of the problems in problem 2, it's going to say use positive exponents only. Because I know some of you guys are going to be tempted to do this. Because you're going to say, oh, but since the x is on the bottom, can I write this? You're going to say, can I write this? X to the negative 3/4 power. Because that negative sign is what told me to go to the bottom in the first place. So can I write it like this instead? X to the negative 3/4 power. You could write the problem that way if it didn't say in the directions use only positive exponents. But because it says use only positive exponents, we can't use that answer in red. Okay, I mean, I know you guys know how to write it, or you guys starting to figure it out because you just saw problem 1 and we just did the opposite journey, and yeah, this is how it's gonna connect in that way so that you can kind of see how it's gonna form the negative exponents. But we're not allowed to write that based on our instructions. Okay, so I just showed you the part in red. Don't leave your answer like that, please. Just leave it in the blue. Just leave it like this. What I'm going to circle right now in blue. That's how I want you guys to leave your answer for this problem. But understand that it does connect eventually, yeah, or it can connect eventually back to this answer in red as well. Okay, but don't write it like that for your final product. Okay, letter B. Let's do letter B. So, wow, there's a lot of y's all over the place. Okay, so this one says I got 3 y's on the outside. Okay, so I'm just going to write 3 y's on the outside. Actually, I'm not going to rewrite the whole problem. Yeah, I'm going to rewrite it the same. So, and it's a 7th root radical of y squared. So let's start seeing what this all is. So I got y to the 3rd, because that's what's on the outside. And then I also have y to the 2/7 power. Okay, so y to the 3rd times y to the 2/7 power. Yeah, when you have the exact same base, right? They both are base y. When it's the exact same base, all you got to do to the powers is add your powers. So you're going to go 3 plus 2/7, and you're going to get y to the 3 and 2/7 power. Okay, so you can leave your answer as a mixed number if you want, or you can turn this into an improper fraction and say, okay, how do I turn a mixed number into an improper fraction? You go times the bottom, so 7 times 3, add the top. So 7 times 3 is 21, plus 2 is 23. So y to the 23 over 7 power. Okay? So either answer is fine. Yeah, either answer is fine. You might just want to ask your own teacher what they prefer as far as answers are concerned. So some teachers, they don't want to see exponents written in mixed numbers. Some teachers, they only want to see exponents written as improper fractions if need be. Yeah, so just ask your teacher what their preference is. Okay, and they'll let you know. Some just might say, just put it either way, that's fine with me too. Okay? All right, next problem. Okay, so what do we have here? So we have 1 over the 6th root radical of a single x and 5 y's. Okay, so everybody's inside the sixth root radical, and everything is underneath the 1. So we're gonna keep everybody underneath the 1, and we're gonna take apart each of these letters. So we have a single x, and he's stuck in a sixth root radical. Okay, so that's why I have 1 on the top, because I have a single x, and I put a 6 on the bottom because he's inside of a sixth root radical. Okay, then I got 5y, so I put the 5 on the top of the fraction, and he's stuck inside of a sixth root radical. So 5/6 is his fraction. Okay, and I know I could rewrite this with negative exponents, but you gotta mind your directions. It says use only positive exponents, so therefore I'm gonna leave my answer like this. Okay, you could write it this way, right? You could write it this way: x to the negative 1/6, y to the negative 5/6. You could write it this way also, but since the directions say use only positive exponents, then please don't write it that way in red. But it does also transform to that as well. Okay, like I said, I don't want you guys to write your answers like that because the directions say use only positive exponents. But if you wanted to see what else it could look like, this is another I guess form it could take on. Okay. All right. So next one, kind of the same as letter B, the one that I just did on the previous slide. So we got y to the negative 5 power, and then we have fourth root radical of y to the third. Okay, so let's transform some of these things. So y to the negative 5 power stays the same, and y, the fourth root radical of y to the third is going to become y to the 3/4 power. Okay, and just like the previous problem, since they have the same base, we're going to add the exponents, right? Because we're multiplying the y's together. We're going this y times that y. And when we're multiplying the same exact base or the same exact letter, the basic process is you add your powers. Okay? So since the bases are the same, we're multiplying y times y. We're going to just add the powers. So we're going to go negative 5 plus 3/4. Okay, so normally we can't just add these up really easily because they don't have the same denominator. So I gotta make them match. So right now this negative 5 is over the number 1. So to make these guys match, I gotta make them have the same denominator. Okay, so hopefully you remember your fractions as far as adding fractions are concerned, as far as how to turn fractions to have the same denominator. You're gonna times the top and the bottom by 4 because then you're gonna make the numbers match at 4 on the bottom. Okay, so when I do that, my numbers transform to become y to the negative 20, because that's negative 5 times 4 over 4 plus 3 over 4. Okay, so when I add my powers up, I get y to the negative 17 over 4 power. Okay, and this is where you got to remember. It says in the directions, use only positive exponents. Right now I have a negative exponent, right? It's negative 17. So just like in the previous problem, letter C, right? I showed you that x to the 1/6, y to the 5/6, right? We can put a negative right next to those two fractions, and that brings those letters x and y back up to the top. It's no longer on the bottom of the fraction because that negative sign included in the exponent, yeah, allows me to bring that x and the y that was on the bottom of the fraction, it allows me to bring it back up. Okay, so right now I have a negative exponent, so this negative exponent is telling me send the y to the bottom, okay, or opposite of where he currently is. So since he's currently on the top of the fraction, yeah, I'm going to send the entire y to the bottom. So when I rewrite this problem with a positive exponent, it's going to be a fraction, and the entire y to the 17 over 4 power got sent to the bottom. Okay, and when you write out this power, try to write it on the smaller side. I know I didn't write it super good. I guess I could have written the y a little bit bigger so that the 17 over 4 looks a little bit smaller, but try to make it look like an exponent as much as you can. I know it's difficult if you don't change how big or how small you write. Okay, I guess I could do a better job of illustrating that point. Yeah, but try your best. Okay, I'll see if I'll let you know if you're writing the numbers too big. Yeah. Okay, next problem. All right, we're on number 3 now. So number 3 is going to say, write your answer using a radical. Okay, so now we're going to start to do what is called simplify, or I guess you can call it evaluate also, but we're going to be actually having to do some some work. Yeah, some simplification with the numbers. And we're going to be doing some circling with the red pen. So let's get ready for that. Okay, so my problem says 9 to the 3 over 2 power. Okay, and that means that I have 3 9s, right? I have 3 9s stuck inside of a square root. So I got 3 9s, 1, 2, 3. And all of that is stuck inside a square root. Okay, so I guess I could circle something now already because I see 2 things that match. So these guys can get circled, right? And if they get circled, they can go outside. So the 9 goes outside. And we're saying to ourselves, okay, the 9 that didn't get circled, can he be broken up into smaller numbers? Because if he can, maybe I can circle those smaller numbers and they can join the 9 that's already out there. So let's see, can 9 be broken up any smaller? Yeah, I think it can. I think it can be broken up into 3 and 3. Yeah, and since they can be broken up into 3 and 3, they match. And you're probably saying, cool, yeah, I found a matching pair, right? And it's a good thing that it's a square root. I only have to find 2 things that match, right? In the previous couple of problems, we didn't have a 2 in that little space. So we had to look for a lot more numbers or letters to match before I circle them. Okay, but in this case, it's a square root, so therefore, just look for 2 things that match. Okay, so the 9 is going to be joined by the 3 that just got circled, and that's going to give me a final answer of 27. Okay, so 9 to the 3 over 2 power transforms into 27. Okay, so hopefully that made sense. Yeah, and all you're doing is you're just following the instructions of what what the radical says, right? Turn the radical into a square root, do some circling, break apart numbers, yeah, do more circling, and connect everybody together. Okay, so this next one, it says 16 to the negative 3/4 power. Okay, so the negative is going to tell me to send the entire 16 to the bottom. Okay, so that's what the negative does, right? He tells me to send the 16 and the 3/4. It says send him to a different location. So let's do that. So let's put a 1. Let's make a fraction, put a 1 on the top, and send the entire 16 to the 3/4 power on the bottom. Okay, so the negative did that, right? So if you're wondering, how did I write that? Well, I was told to write that because that's what the negative does. He tells me to pick up the entire thing and put them in a different location. Okay, so since 16 is kind of like, since it's like 16 over 1, you can think of it as 16 over 1. The negative says send the 16 to the bottom, and send the one that was on the bottom, send him to the top, right? So it tells him, kind of like switch places, I guess you can think of it that way. Okay, so now let's listen to what the radical is saying. And the radical is saying, okay, we got 3 16s, and these 3 16s are going to be shoved into a 4th root radical. So let's make a 4th root radical, and let's shove 3 16s in there. Okay, so do I have 4 16s that I can circle? Unfortunately not. So since I don't have 4 16s that I can circle, I got to break apart the 16s into smaller numbers. So I still got my fraction. Actually, I made this equal sign a little bit too high. Because if I write the 1, it's going to be kind of like inside the square root symbol also. Or not the square, the radical symbol also. So I might need a little more space. I might have to page expand. So 1 up top. And let's break apart these 16s into smaller pieces so I can find stuff that I can circle. So good thing I know that 16s are known as a bunch of 2's all multiplied together. Okay, so 1/16 is known as 2 times 2 times 2 times 2, 4 2's all multiplied together. So I'm going to write 4 2's 1 time, 2 time, and 3 times, 1 more time, because I have 3 16s, right, that I have to represent. So this first 16 right here is the first 4 2's right here in the top left corner. The second 16 is my second set of 2's right here in the top right corner. And the last 16, the one on the bottom, is my last set of 2's in the middle on the bottom. Okay, then I'm going to get my red pen and I'm going to look for things that match, 4 of them that match, and I see all these 4 match. And I circle the 4 things that match, so therefore I circled 2 3 times, so therefore it's going to become 1 over 2 times 2 times 2, right? Because I circled 2 3 times, so that's why I have 2 times 2 times 2 on the outside, and nothing got left inside the radical symbol, right? There's nothing left outside the circle, so therefore the radical symbol disappears. So that's why you don't see the radical symbol anymore. and then I just multiply all my two 2's together, and I get 1 over 8. And there you go. Okay, next problem. Okay, next one is 64 to the 3/8 power. So this basically says 3 64s, right? 3 64s, all of them shoved into an 8th root radical. So let's shove, actually I made this radical a little bit too big. I don't have to make it this big for this first try. So I'm just going to put 3 64s. 64, 64, 64. Okay, so do I have 8 64s that I can circle? No, I don't. I don't have 8 64s. So I got to break up 64 into smaller pieces. So, good thing I know that a single 64 is known as 6 2's, right? 2 times 2 is 4, then 8, then 16, then 32, then 64. Okay, so a single 64 is known as 6 2's all multiplied together. Okay, so I'm going to write 3 sets of 6 2's because I have 3 64s. So let me write 6 more 2's. That's my second 64. And let me write 6 more 2's because that's my third 64 that I had initially in the problem. Okay, and now my job is to get my red pen and circle 8 things that match. So I got 6 2's in the top row, so I'm going to take all 6 of them from the top and take 2 from the bottom. So that's a total of 8 right there. Okay, and then I am going to circle some more. So let's see, let me circle 8 more 2's. So I got 8 2's right there, so I'm going to circle 8 2's right there. Yeah, and I have 2 sets of 8 2's circled. So that means 2 2's are going to jump on the outside. So 2 times 2 on the outside. And I have 2 squared on the inside. Okay, and you're probably wondering, why didn't you write that as a 4? Normally you just go ahead and you put everything together again right away. So why did you write it as 2 squared when, like I said, every single problem up to this point, you never did that. You always just multiplied everybody together and put a 4 just like that. Okay, and let me show you why. Okay, and you're going to hate me for this, and I'm really, really sorry. I didn't make up this rule. I'm just delivering the message, but here's what happens to happen next. Okay, you got to do what is called simplification. And the best way I can relate this to you is think of fractions. Okay, so if you had a fraction that said this, 2 over 8. Yeah, if you had that fraction 2 over 8, would you be allowed to leave your answer like that? Your final answer is 2 over 8. No, you wouldn't, because you know you can divide the top and the bottom by 2, and you know that this fraction will become eventually 1 over 4. Okay, so that's part of the rules with fractions. It's mandatory to simplify it. Okay, so just like when you see the radical written just like this, you see an 8th root radical, you see 2 squared inside that 8th root radical, and here's what you're obliged to do. Okay, it is mandatory to reduce this radical along the same logic as how I reduced 2 over 8 to make it into 1 over 4. Because 2 and 8 can divide by 2, you write 2 over 8 as 1/4. And just like these powers, right, you see a 8, right, it's an 8th root radical. You see a power of 2 connected to this 2, and you can say to yourself, well, I think I can divide the 8 and the 2 by a common number, and that common number I can divide by is 2. Okay, so let me actually put this outside number together. So I can put this 4 together. That's no big deal. Okay, there's no harm with that. I should have actually done that from the beginning, but I forgot. So I'm going to reduce the 8 over here on the outside, right, the one in this little space, and I'm going to reduce the 2 that is the power of the 2. And I'm going to reduce it by a number they can both divide by, which is 2. So when I rewrite this problem, look how it's different. And there's your final answer. Okay, so all I did was I reduced my powers, or the little tiny numbers. I can't really call it a power because 8 is not a power. Okay, it is in a power if I turn it into exponent form. It's in the bottom of the fraction, right? But yeah, you just think of it as I reduced the tiny numbers, the numbers that are written a little bit tinier. Okay, not the normal size 8, the normal size 2, right? These are my numbers that I write a little bit tinier because they got to go in a certain spot. Okay, so I reduced them, and there's my final answer. Okay, and the logic, like I said, the logic you follow is the exact same logic that you would follow when you simplify fractions. Okay, all right, so let's look at letter D. And letter D, it gives you a hint. It says use what is called product of powers. Okay, so it's much easier to write this problem vertically. So I'm going to write 8 to the 1/4 power in the parentheses. And this whole entire parentheses is going to be to the 5/6 power. So basically you have two powers right next to each other, and all they have in between them is a parentheses symbol. Okay, so whenever you see a setup just like this, where you literally see two powers right next to each other, and the only thing that is separating the two powers from each other is a parentheses, you basically have what is called product of powers. And what that means is you're just going to do exactly what the name of this thing says. You're going to multiply them, because that's what product means, multiply. So you're going to multiply the powers. So when you multiply fractions, you got to remember the rules, right? Top times top, bottom times bottom. So I'm not gonna change the 8 because I'm only multiplying the powers, or I'm only multiplying the exponents. So 1 times 5 makes 5 on the top. 4 times 6 makes 24 on the bottom. Okay? Alright, so then this is going to be turned into radical form because that's what the directions say, right? Write your answer using a radical. So we got 5/8 stuck inside of a 24th root radical. Okay, wow, this is a pretty intense radical. So let's write 5/8 in there. And I guess I can write it that big. So 1, 2, 3, 4, 5. So I got 5/8 inside my 24th root radical. Okay. And do I have 24/8 that I can circle? I don't think so. So let me rewrite these 24/8. I'm sorry, these 5/8 as a bunch of 3s. And let's see if I can circle them as a result. So still yet, it's a 24th root radical. And let's rewrite all of these 8s as a bunch of 2s. So I know that a single 8 is known as 2 times 2 times 2. So there's one of my 8s. There's 2 of my 8s, right? Because each time I write 3 2s, that's one of my 8s. And I got 5 of them, so I got to make sure I write 5 sets of 2s, right? So that's 3 8s so far. And this is 4 8s so far. And there's my 5th 8, right? Because like I said, each time I write 3 2s, that's known as 8. And you're probably thinking, what? That's 8? I think that's 6. No, you multiply the 2s together, not add them. Okay? And then I get my red pen out and I see, ooh, can I circle 24 2s? Do I actually have 24 2s? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, I don't have 24 2s, so I can't do that. Okay, so I'm going to combine my 2s together. I'm not going to multiply to make one ginormous number. Watch what I do. Okay, I know I'm in a 24th root radical. I know I have 15 2s, so I'm going to write this as 2 to the 15th power. And then I'm going to say, oh, the previous problem said that when my two tiny numbers, right, like the 24 and the 15 in this case, or in the previous problem, the 8 and the 2, when my two tiny numbers are divisible by a common number, well, let's do it, right? Because I can do what is called simplification, right, in that sense. So what number does 15 and 24 not multiply, divide by in common? And you can say, I think it divides by 3. Yeah, they both divide by 3. So if I do that, 24 will become 8, and the 2 will become 5. And there's my final answer. Okay, I know this is confusing. Every year the kids get confused, right? Because we're throwing basically like a ton of problems at you all at once. So kids always get confused in this. So just like this is a video. You're lucky. In the previous years, the kids had one chance to get this lesson learned, and that's all they had, one shot. Okay, there was no video that they could rewind and rewatch and rewatch and rewatch. And we used to do this lesson all in one day. That was the more intense part, right? So they had to do every single problem that we're going to split into 2 pieces, into 2 parts, all in one day. So it was even more crazy in the past. Okay, so hopefully you can appreciate this extra time that you get to digest the information. Okay, all right, moving on, letter E. Okay, so what do we got? We got 64 to the 2/3 power on the top, and we got 64 to the 3 over 2 power on the bottom. So, okay, I'm not going to rewrite the problem this time and in my own writing with the exponents vertically because I think I need the space. So I'm just going to do whatever the power says. So on the top it says stick 2 64s in a 3rd root radical, or you can just call it a cube root. So I'm going to stick two 64s in there. So 64 and 64, okay? Because that's what I was instructed to do, right? You got to think of math as a foreign language, where the symbols and the numbers in certain spots, they tell you exactly what your job is or what you got to do. So I'm going to write it exactly how the instructions were laid out. It said write two 64s inside of a third root radical. So I did that, okay? Then on the bottom, the instructions are write three 64s in a square root. Okay, so I'm not making this up. I'm just getting my instructions from how the problem is written. Okay, so if you understand how math is written and you can translate it, it's not going to be that bad. Yeah, but when students don't study in the sense that math is like a foreign language, then you think of it as, how do you get this? How are you knowing how to write this? Who's telling you this? And my response is, the problem is telling me to write it like this. Okay, you just got to know how to read it and understand the message it's trying to say. Okay, so let's see, is there anything I can circle? Well, I think I can circle something on the bottom because I see two things that match. So I can circle these guys. I don't see three 64s on the top, so I think I got to rewrite those guys into smaller pieces. So let's rewrite my 64s up top so that I can circle things that are in threes. And I think 64 is known as 4 times 4 times 4, right? So that's a single 64. And the other 64 is going to be 4 times 4 times 4. And I wrote it purposely like that. I didn't write it as 8 times 8, or I didn't write it as 2 times 2, and a lot of 2's multiplied together. I wrote it as 4s because I knew that I needed to find 3 things that match. So I kind of used my experience to get me through this top part, which eventually you can do too if you do enough math problems. Okay. And on the bottom, I circled a 64, so that goes on the outside. So I can bring that on the outside. And then I can rewrite the 64 that didn't get circled. I can rewrite him as 8 times 8. And you're probably saying, why didn't you write him as 4 times 4? And my response is because I'm looking for 2 things that match. So wouldn't 8 times 8 be better? Okay. And you're going to be like, oh my goodness, how'd you know that? And I'm just going to say, you just got to do math enough times, you got to practice it, and it eventually gets easier. Okay. Don't think you can get the hang of this after just one problem. It's not going to happen. You just got to keep on practicing. Okay. So let's circle 3 things that match up top because that's my instructions for the top. And let's circle 2 things that match in the bottom because that's my instructions for the bottom. Okay. All right, so far so good. Okay, so let's see what I got. And on the top, yeah, I think I'm running out of space here. Okay, so on the top I get 4 times 4, and you're probably wondering, why aren't you putting them together into a big number? Well, because I know I have to simplify these fractions, so I don't want to put everything into one ginormous number. I want to keep things on the smaller side. And on the bottom, it's 64 times 8. Okay, so I'm going to simplify my fraction based on these smaller numbers. So I know that the 4 and the 8, right? The 4 and the 8 can reduce. So I divide the top by 4, I get 1. Divide the bottom by 4, I get 2. So all I'm doing is I'm simplifying my fractions. Okay. Then I can look at the other pair of numbers, the 4 and the 64. Divide top and bottom by 4. Top becomes 1. Bottom becomes 16. Okay, so what do I have at the end? Well, 1 times 1 is 1. 16 times 2 is 32. And there's my final answer. Okay. All right, so I know that was kind of intense. Yeah, you're probably wondering, whoa, what just happened? This is a video, people. Just rewind. Okay. Okay, last one. Another one that's going to get kind of crazy. So, like I said, just rewind if you got it. Okay. So basically, you have a fraction, 16 over 81, that's inside of a parentheses that is controlled by the power 3/4. So you got to understand, yeah? The power 3/4 controls the entire contents of the parentheses. So it controls the 16, it controls the 81. So the 3/4 basically says this message. You're going to grab 3 16s, you're going to grab 3 81s, and you're going to put all of those 16s and 81s into a 4th root radical. Okay? That's the instructions I got based on what I just read. Right? I'm going to make a big, ginormous radical symbol, and I'm going to stick 3 16s inside there, and I'm going to put 3 81s inside there. Okay, and that's the instructions I got from the radical. I'm not making this up, people. Right? I'm just listening to exactly what the problem is telling me to do. Okay, and next I'm going to look for 4 things that match, and if I find 4 things that match, Well, I'm going to circle them. I'm going to pull them on the outside. So do I have anything that matches? No, I only have 3 things, so therefore nothing gets circled yet. So let's break apart the 16 and the 81 into smaller stuff. Okay, so I think I have to make this radical a little bit bigger because I got to break it up into tiny numbers. Okay, so 16 I know is the result of 1, 2, 3, 4 2's. So I'm going to write 4 2's 3 times. Right? I read it 3 times because I got 3 16's. And then I'm going to write the 81 into smaller pieces. And I know 81 is the result of 3 written 4 times. Right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I'm going to rewrite the 81 as 4 3's. And I'm going to make 3 groups of him because I got 3 81. So I got to write 3 sets of 4 3's. Okay. Then I'm going to get my red pen and I'm going to circle 4 things that match. And I got a whole bunch of things that match 4 times. So I got 3 2's on the top, and I got 3 3's on the bottom. And I don't think I left anything outside, right? I don't think there's nothing that is not circled, right? Everything got circled. So since everything gets circled, the radical disappears. So keep this in mind. When you bring these 2's and 3's on the outside, you gotta mind their location. So since the 2's are on the top of the fraction, when they get pulled on the outside, they better stay on the top of the fraction. And the 3's, they're currently on the bottom of the fraction. So when they get pulled out, they better stay on the bottom of the fraction as well. So notice what I'm doing, right? I'm taking into account that when I take these 2's and 3's on the outside, they gotta go in a certain spot. Okay? So 2 times 2 times 2 up top is 8. 3 times 3 times 3 on the bottom is 27. And there's your final answer. All right, so I think the next slide is the homework already. So I hope this made sense. Good luck on your homework, and I'll see you in class. Bye-bye.